Electricity generation is the process of generating electric power from other sources of primary energy. The fundamental principles of electricity generation were discovered during the 1820s and early 1830s by the British scientist Michael Faraday. His basic method is still used today. Electricity is generated by the movement of a loop of wire, or disc of copper between the poles of a magnet. For electric utilities, it is the first process in the delivery of electricity to consumers. The other processes, electricity transmission, distribution, and electrical power storage and recovery using pumped storage methods are normally carried out by the electric power industry. Electricity is most often generated at a power station by electromechanical generators, primarily driven by heat engines fueled by chemical combustion or nuclear fission, but also by other means such as the kinetic energy of flowing water and wind. Other energy sources include solar photovoltaics and geothermal power. History. Central power stations became economically practical with the development of alternating current power transmission, using power transformers to transmit power at high voltage and with low loss. Electricity has been generated at central stations since 1882. The first power plants were run on water power or coal, and today we rely mainly on coal, nuclear, natural gas, hydroelectric, wind generators, and petroleum, with a small amount from solar energy, tidal power, and geothermal sources. The use of power lines and power poles have been significantly important in the distribution of electricity. Methods of generating electricity. There are 7 fundamental methods of directly transforming other forms of energy into electrical energy. Static electricity, from the physical separation and transport of charge. Electromagnetic induction, where an electrical generator, dynamo or alternator transforms kinetic energy into electricity. This is the most used form for generating electricity and is based on Faraday's law. It can be experimented by simply rotating a magnet within closed loops of a conducting material. Electrochemistry, the direct transformation of chemical energy into electricity, as in a battery, fuel cell or nerve impulse. Photoelectric effect, the transformation of light into electrical energy, as in solar cells. Thermoelectric effect, the direct conversion of temperature differences to electricity, as in thermocouples, thermopiles, and thermionic converters. Piezoelectric effect, from the mechanical strain of electrically anisotropic molecules or crystals. Researchers at the U.S. Department of Energy's Lawrence Berkeley National Laboratory have developed a piezoelectric generator sufficient to operate a liquid crystal display using thin films of M13 bacteriophage. Nuclear transformation, the creation and acceleration of charged particles. Static electricity was the first form discovered and investigated, and the electrostatic generator is still used even in modern devices such as the Van de Graaff generator and MHD generators. Charge carriers are separated and physically transported to a position of increased electric potential. Almost all commercial electrical generation is done using electromagnetic induction, in which mechanical energy forces an electrical generator to rotate. There are many different methods of developing the mechanical energy, including heat engines, hydro, wind and tidal power. The direct conversion of nuclear potential energy to electricity by beta decay is used only on a small scale. In a full-size nuclear power plant, the heat of a nuclear reaction is used to run a heat engine. This drives a generator, which converts mechanical energy into electricity by magnetic induction. Most electric generation is driven by heat engines. The combustion of fossil fuel supplies most of the heat to these engines, with a significant fraction from nuclear fission and some from renewable sources. The modern steam turbine currently generates about 80% of the electric power in the world using a variety of heat sources. Turbines. All turbines are driven by a fluid acting as an intermediate energy carrier. Many of the heat engines just mentioned are turbines. Other types of turbines can be driven by wind or falling water. Sources include steam, water as boiled by nuclear fission, the burning of fossil fuels. In hot gas, turbines are driven directly by gases produced by the combustion of natural gas or oil. Combined cycle gas turbine plants are driven by both steam and natural gas. They generate power by burning natural gas in a gas turbine and use residual heat to generate additional electricity from steam. These plants offer efficiency of up to 60%. Renewables. The steam is generated by biomass, solar thermal energy, solar parabolic troughs and solar power towers concentrate sunlight to heat a heat transfer fluid, which is then used to produce steam. Geothermal power. Either steam under pressure emerges from the ground and drives a turbine, or hot water evaporates a low-boiling liquid to create vapor to drive a turbine. Ocean thermal energy conversion uses the big difference between cooler deep and warmer surface ocean waters to run a heat engine. Other renewable sources. That is artificially produced inside the chimney by heating it with sunlight, and are more properly seen as forms of solar thermal energy. Reciprocating engines. Small electricity generators are often powered by reciprocating engines burning diesel, biogas or natural gas. Diesel engines are often used for backup generation, usually at low voltages. However, most large power grids also use diesel generators, originally provided as emergency backup for a specific facility such as a hospital, to feed power into the grid during certain circumstances. Biogas is often combusted where it is produced, such as a landfill or wastewater treatment plant, with a reciprocating engine or a microturbine, which is a small gas turbine. Photovoltaic panels. Unlike the solar heat concentrators mentioned above, photovoltaic panels convert sunlight directly to electricity. Although sunlight is free and abundant, solar electricity is still usually more expensive to produce than large-scale mechanically generated power due to the cost of the panels. Low-efficiency silicon solar cells have been decreasing in cost, and multi-junction cells with close to 30% conversion efficiency are now commercially available. Over 40% efficiency has been demonstrated in experimental systems. Until recently, photovoltaics were most commonly used in remote sites where there is no access to a commercial power grid, or as a supplemental electricity source for individual homes and businesses. Recent advances in manufacturing efficiency and photovoltaic technology, combined with subsidies driven by environmental concerns, have dramatically accelerated the deployment of solar panels. Installed capacity is growing by 40% per year, led by increases in Germany, Japan, California and New Jersey. Other generation methods. Various other technologies have been studied and developed for power generation. Solid-state generation is of particular interest in portable applications. This area is largely dominated by thermoelectric devices, though thermionic and thermophotovoltaic systems have been developed as well. Typically, TE devices are used at lower temperatures than TI and TPV systems. Piezoelectric devices are used for power generation from mechanical strain, particularly in power harvesting. Beta-voltaics are another type of solid-state power generator which produces electricity from radioactive decay. Fluid-based magneto-hydrodynamic power generation has been studied as a method for extracting electrical power from nuclear reactors and also from more conventional fuel combustion systems. Osmotic power finally is another possibility at places where salt and fresh water merges. Electrochemical electricity generation is also important in portable and mobile applications. Currently, most electrochemical power comes from closed electrochemical cells, which are arguably utilized more as storage systems than generation systems. But open electrochemical systems, known as fuel cells, have been undergoing a great deal of research and development in the last few years. Fuel cells can be used to extract power either from natural fuels or from synthesized fuels, and so can be viewed as either generation systems or storage systems depending on their use. Economics of generation and production of electricity. The selection of electricity production modes and their economic viability varies in accordance with demand and region. The economics vary considerably around the world, resulting in widespread selling prices. For example, the price in Venezuela is 3 cents per kilowatt-hour, while in Denmark it is 40 cents per kilowatt-hour. Hydroelectric plants, nuclear power plants, thermal power plants and renewable sources have their own pros and cons, and selection is based upon the local power requirement and the fluctuations in demand. All power grids have varying loads on them, but the daily minimum is the base load, supplied by plants which run continuously. Nuclear, coal, oil and gas plants can supply base load. Thermal energy is economical in areas of high industrial density, as the high demand cannot be met by renewable sources. The effect of localized pollution is also minimized as industries are usually located away from residential areas. These plants can also withstand variation in load and consumption by adding more units or temporarily decreasing the production of some units. Nuclear power plants can produce a huge amount of power from a single unit. However, recent disasters in Japan have raised concerns over the safety of nuclear power, and the capital cost of nuclear plants is very high. Hydroelectric power plants are located in areas where the potential energy from falling water can be harnessed for moving turbines and the generation of power. It is not an economically viable source of production where the load varies too much during the annual production cycle and the ability to store the flow of water is limited. Renewable sources other than hydroelectricity due to advancements in technology, and with mass production, their cost of production has come down and the energy is now in many cases cost comparative with fossil fuels. Many governments around the world provide subsidies to offset the higher cost of any new power production, and to make the installation of renewable energy systems economically feasible. However, their use is frequently limited by their intermittent nature. If natural gas prices are below $3 per million British thermal units, generating electricity from natural gas is cheaper than generating power by burning coal. Production. The production of electricity in 2009 was 20,053 TWh. Sources of electricity were fossil fuels 67%, renewable energy 16%, and nuclear power 13%, and other sources were 3%. The majority of fossil fuel usage for the generation of electricity was coal and gas. Oil was 5.5%, as it is the most expensive common commodity used to produce electrical energy. 92% of renewable energy was hydroelectric, followed by wind at 6% and geothermal at 1.8%. Solar photovoltaic was 0.06%, and solar thermal was 0.004%. Data from OECD 2011-12 Factbook. Data source IEA OECD. Total energy consumed at all power plants for the generation of electricity was 4,398,768 kTOE, which was 36% of the total for primary energy sources of 2008. Electricity output was 1,735,579 kTOE, efficiency was 39%, and the balance of 61% was generated heat. A small part of the heat was utilized at cogeneration heat and power plants. The in-house consumption of electricity and power transmission losses were 289,681 kTOE. The amount supplied to the final consumer was 1,445,285 kTOE, which was 33% of the total energy consumed at power plants and heat and power cogeneration plants. Historical results of production of electricity. Production by country. The United States has long been the largest producer and consumer of electricity, with a global share in 2005 of at least 25%, followed by China, Japan, Russia, and India. As of January 2010, total electricity generation for the two largest generators was as follows: USA 3992 billion kilowatt-hour and China 3715 billion kilowatt-hour. List of countries with source of electricity 2008. Data source of values is IEA OECD. Listed countries are top 20 by population or top 20 by GDP in Saudi Arabia based on CIA World Factbook 2009. Solar PV is photovoltaics. Bio other equals 198 TWh plus 69 TWh plus 4 TWh. Cogeneration. Cogeneration is the practice of using exhaust or extracted steam from a turbine for heating purposes, such as drying paper, distilling petroleum in a refinery, or for building heat. Before central power stations were widely introduced, it was common for industries, large hotels and commercial buildings to generate their own power and use low-pressure exhaust steam for heating. This practice carried on for many years after central stations became common and is still in use in many industries. Environmental concerns. Variations between countries generating electrical power affect concerns about the environment. In France, only 10% of electricity is generated from fossil fuels, the US is higher at 70% and China is at 80%. The cleanliness of electricity is dependent its source. Most scientists agree that emissions of pollutants and greenhouse gases from fossil fuel-based electricity generation account for a significant portion of world greenhouse gas emissions. In the United States, electricity generation accounts for nearly 40% of emissions, the largest of any source. Transportation emissions are close behind, contributing about one-third of U.S. production of carbon dioxide. In the United States, fossil fuel combustion for electric power generation is responsible for 65% of all emissions of sulfur dioxide, the main component of acid rain. Electricity generation is the fourth highest combined source of NOx, carbon monoxide, and particulate matter in the U.S. In July 2011, the UK Parliament tabled a motion that levels of emissions from nuclear power were approximately 3 times lower per kilowatt-hour than those of solar, 4 times lower than clean coal and 36 times lower than conventional coal. Though solar PV generation is positioned as environmentally friendly, fabrication of PV cells utilizes substantial amounts of water in addition to toxic chemicals such as phosphorus and arsenic. These are often overlooked when promoting PV. Because of strict environmental regulations in the United States, for example, PV fabrication is often performed in countries with lower standards, such as China, which produces approximately half the world's PV panels. Water consumption. Most large-scale thermoelectric power stations consume considerable amounts of water for cooling purposes, and boiler water make up 1 liter per kilowatt-hour for ones through, and 1.7 liters per kilowatt-hour for cooling tower cooling. Water abstraction for cooling water accounts for about 40% of European total water abstraction, although most of this water is returned to its source, albeit slightly warmer. Different cooling systems have different consumption versus abstraction characteristics. Cooling towers withdraw a small amount of water from the environment and evaporate most of it. Once-through systems withdraw a large amount but return it to the environment immediately, at a higher temperature. See also. References. External links: Electricity, a Visual Primer, Power Technologies Energy Data Book, now on PBS, Power Struggle, This Week in Energy, Electricity, From Tabletop to Power Plant, The Power Sector in Lebanon via Carbone.